Okay, the last thing I want to show you, I'm going to leave the analysis here entirely. I'm going to show you a very brief example of a multi-operator event in moving part study. These are quite a bit more sophisticated. I could do a 1 or 2 hour webinar just on multi-operator moving part studies. But I wanted to give you a quick view of what these types of studies do look like. So let's go ahead and load the tutorial example that's included with the software. I'm going to pan over here a little bit. I'm just typing commands in so you can see what I'm doing. I'm going to zoom, window. You can see I've got a little car and a person in there, and I'm going to zoom into this area here. So I have a workplace, right, left, operator, workplace. I've got a line I drew, it's called my part line. That's one of the things that you'll specify as the vehicle line. It does need to be a straight line. And and that's pretty much it. So I'll go into Workplace Planner. I'm going to open moving study, which I have right here. And what we're going to see is something a little bit different now in our specification, our task. First of all, one thing you'll notice is that I do have my operators. In this case, I have a processing time. I use P, that's fine. And you have your W for your walk time. So M or P can be your manual processing time, machine dependent processing time, or manual processing time. It doesn't matter. It's just a user preference. Depends on your reporting. Some people want to determine in their process sheet whether this was a machine dependent processing time or a worker dependent manual processing time. The operator, OR1, OL1, station 1, operator right, operator left. We have our processing time specified. You can see here, the rest of these are walk times. Now, this is a pretty standard task. You can see I'm walking to rack 1, and rack 1 has a fixed location, and I gave it the name rack L1. Now, also, remember that the names of the operators and the names of the locations that the operators perform work at must be letters and or numbers and or dashes and underscores. No other characters are allowed. You cannot put spaces in there. You cannot put periods in there. You can't use exclamation marks. You can't use slashes. So be very careful when you're specifying your operator names and your location names. I would also recommend that you keep them simple. Now, what about this one? This is a little weird. What does at 1C mean? What does at 7L mean? Okay, well, if we go to some of our context-sensitive help, we have a little tutorial on this. That's probably a good way to get a look at that. I'm going to do a moving part analysis. And as I go down here, you'll see this little grid. There are actually 2 grid patterns the software supports. This one grid pattern, the number starts here at the beginning, 1 of the vehicle, and goes to N, whatever N needs to be. It's a user-defined value in the settings tab. Could be 7, could be 10, could be 15, whatever. 1 to 100, 1 to 99, actually. The next character in this location specification is left, center, or right. So am I left of the vehicle as I was sitting in the vehicle, or am I right of the vehicle? So at 1 left would be the front left corner. At 1 right would be the front right corner. At 7 left would be the left rear corner. At should be a 7R, apologize, should be the back right corner. So the point is that this language is allowing me to specify where in the vehicle I'm at. Remember, the at indicates that this is a relative location because the vehicle is moving. This is not a fixed spot. At 1L will be at many different locations as the drawing moves on. Now, in this particular specification, you can even use decimals if you want. I can specify a distance down, and well, I'm not going to detail on that. But if you want to be more accurate, the answer is there are ways to do that. So in this case, obviously I'm at the front center, maybe putting the logo on the front grille. 7 left, I'm in the left-hand side back, maybe putting in the rear light, and so on as the work is performed. Once again, the sequence of tasks needs to be specified. If there's no interdependency between operator on the right and operator on the left, they're just doing their work. You could do all of the left operator first and all the right operator second, which you can see was done here. It would only be if I have a synchronization event where I'm specifically requiring, let's say, a dashboard installation or a headliner installation, where operator 1 and 2, right, left, have to both be available at the same time. Would I list all the tasks before that headliner event of left and right, then have my synchronization event, then list all the tasks that are being done after that event. Okay, let's do a quick calculation. And you can see here's the operator paths. I'm going to go ahead and make that full screen so it's a little easier to see. And let's go to our paths. We could even put arrows on that. That's 6 and 6 should look pretty good. Let's see here. Let's do maybe. Yeah, the arrows are showing up a little bit better there. Operators, I have both my operators specified. I do the person block. I do have a starting location for the 2 operators. I do have their speeds. I got 2 different colors for the operators. One's red and one's yellow. Start locations right and left. I can delay them. I could make the operator wait before they start work. I can even allow the operator to work in the prior station so many feet. In other words, once the vehicle shows up before this station, they could cheat and walk into the prior station a certain amount of distance to get started. I also can allow the person to work a certain amount of distance in the following station. They're allowing me to increase the actual cycle time for this operator. Some companies want that to happen. And once again, I can add a delay. So there's a bunch of options here. When we deal with the part, we have a car. Car operates at a certain speed and it's a certain size. And that's just an overall rectangle. It's going to be placed around the car as it moves. We also have an AutoCAD block that I've specified, so you can pick any block you want for your car. Once again, this is a 3D block. Those are 3D people. If I moved into a 3D view, we could see this working in 3D as well. We'll probably do that here towards the end on the animation. Although AutoCAD, at least my machine, when seeing in 3D in the editing environment, isn't the best place to do that work. Okay, so we have our routings, we have our people and our paths for our product. So we're going to do a moving part study. It actually saw the ats in here and it figured out we were probably doing a moving part study. It did the calculation. The diagram was updated. One thing that you'll notice how these operators are working here. Everything seems to be fine. What if I slowed down the vehicle? If I slowed down the vehicle, you would think the operators would be forced more closer. In other words, they wouldn't go this far into the station, right? So let's see what happens when I do that. So I'm going to go to the part, which is the car, and I'm going to slow it down. It's not going to go 40 feet per minute. It's going to do 30. Okay. So now when I go into my routings and I recalculate, let me move over here so you can see them. These lines will get shorter. See that? Because the operator cycle time, they now have more time to do other things. The vehicle is taking a longer cycle time in the station. Likewise, if I went in and I changed that and I moved the line rate up to 50, one of these operators can't complete their work in time. Look what happened. So that's not going to work out so well, is it? So let's go back to changing the vehicle speed down to 40. Routings tab and calculate. Okay. And what you're also noticing, once again, I can go into AutoCAD, which is just go to AutoCAD. Once I'm in AutoCAD, I could say, well, gosh, what if I were to start, move the start location maybe, over here, which isn't going to make a big deal. It's only happened once. What if rack L1, that doesn't look like it's in a very good spot. What if rack L1 was actually placed over here? What else doesn't look good? That's probably the worst one, isn't it? This one looks pretty good. That's a nice triangle. These are nice triangles. I don't see anything wrong there. How about over here? What do we have? Looks like rack R1 as well would be better put maybe a little bit closer over to here. What does that do? Okay, so I've moved those locations. What I can do now is I can take a look at my cycle time. So 121 feet, 124 feet, okay? Keep that in mind. Just over 80 seconds maximum cycle time. Recalculate. A little cleaner line, isn't it? 111 feet, 108 feet. We've saved ourselves about 3 seconds of our cycle time. And our drawing is updated accordingly. And lastly, of course, I still have my lean charts per operator. I still have my reports. For each of the operator cycles, my drawing, and my animation. Looks like rack right one, not such a good spot. It is okay on that one, but it could still be better in a different area. Okay, hopefully this has been a helpful introduction to Workplace Planner, both static and moving studies. As always, if you have questions, feel free to contact us. We're always glad to help. There's a question here, is it possible to export the routing file directly from Assembly Planner? So in the case of a moving part study, the answer is actually yes. The file that we're looking at here in line balancing, this file here, okay, which is the list of tasks that each of the operators are performing in a moving part study. If you think about it, how would you know what tasks the right operator does and the left operator does in this station? Well, it's because you did an assembly line balancing study. Now, the problem with the assembly line balancing study is it may have estimates for walking, but it won't know the actual walking because in line balancing, you're moving the task to the station. So this is really a post-line balancing validation of cycle time, taking into account walking. So yes, in the line balancing module in Assembly Planner, I can export to Workplace Planner the list of tasks and task times and task descriptions for each operator in this station. And then I do my calculation, the software updates the walk times, generates the diagram, and gives me a much better view of my cycle time. I may find in my Workplace Planner study, if I was really close to the cycle time, that there's just no way to perform this work, in the cycle time that we thought it would take when we were doing line balancing because the walking is so substantial. In that particular case, obviously the first goal would be to fix the layout so the walking isn't substantial. But if that can't be done, I would have to go back into Workplace to Assembly Planner, modify my line balancing study, republish it, and revalidate my results. One nice thing about the fact that Workplace Planner can parse the codes, MTM, MODAPS, most, is the fact that if I've got my predetermined time study in Assembly Planner and I did my line balancing in Assembly Planner, when line balancing exports the tasks to Workplace Planner, it will also export the predetermined time codes, allowing Workplace Planner to parse those predetermined time codes and then add the predetermined time codes for the walk tasks. So you do end up at the end of Workplace Planner with a very accurate layout-based visual and quantitative predetermined time study validation of your cycle time. All right, everyone. Thanks for your time. If you have any questions, as always, please contact us here at ProPlanner. Thank you.